Hello, and welcome to Features of Core Instruction Part 1, Mathematics in Practice. This is part of a series of learning modules developed by the Rhode Island Intensive Math Intervention Project. My name is Melinda Griffin with the American Institutes for Research, and I'll be guiding you through this session. Our goals for this session are to consider the progression of mathematical domains across grade levels, to learn about the standards for mathematical practice and how they progress through the grade levels, and to understand how the content and practice standards interact for standards alignment. The focus of this module is on core instruction rather than Tier 2 or Tier 3. By core instruction, we are referring to instruction that is received by all students in the general education classroom. This instruction is focused on grade level standards and incorporates both content and practice standards. It's often referred to as Tier 1 instruction. The first section we're going to look at is the progression of math content domains. As you know, mathematics content rarely begins and ends with a single grade level. In particular, the Common Core standards allow for math concepts to move from emerging to developing to mastery across the time span of 2 or 3 grade levels. We're going to start out by taking a look at how these math content domains progress through grades K through 8. The chart you see on your screen shows a progression of mathematical concepts from grade kindergarten through 8. You can see there are some domains that are included at a large range of grade levels, such as operations and algebraic thinking, or geometry. Others start in a simpler domain and then progress to more complex ones, such as starting with counting and cardinality in kindergarten and progressing on to number and operations in base 10. Now we're going to take a look at some of these clusters of domains and how they work together across the grade levels. The first group we'll look at is the progression of numbers and operations as they move through the grade levels. We'll start with the domain of counting and cardinality in kindergarten and also talk about number and operations in base 10, number and operations including fractions, and the number system. Let's take a look at how the mathematical concepts build across these grade levels. Students in grades K through 2 are just developing their concept of numbers and how numbers can be used to represent quantities. They start to understand how numbers are organized in the base 10 system, and they begin with basic operations of adding and subtracting with whole numbers. As students move into grades 3 through 5, they begin to use their place value understanding and combine that with properties of operations to do multi-digit arithmetic. They'll learn how to multiply and divide whole numbers, and they also start to work with fractions. They'll understand that fractions are numbers as well, and they'll include things such as equivalence and ordering as they learn how fractions fit into the number system as they understand it. Decimals also come about at this point, and students will move to using operations both with whole numbers and with fractions and decimals across adding, subtracting, multiplying, and dividing. As students move into the middle grades, they'll continue to work with dividing fractions to perfect that operation, and they'll also be able to compute fluently with multi-digit numbers. This is where we see fluency coming in at this point. We'll expect them to apply and extend their previous understandings of the number system to also include rational numbers at this point. That would be signed numbers. And they'll be able to add, subtract, multiply, and divide rational numbers. We'll also talk a little bit about approximating irrational numbers as students start to develop a full sense of what the number system is and how those numbers will be used as they continue their study in mathematics. Domains centered on numbers and operations provides a foundation for other domains. We're going to take a look next at the progression of operations in algebraic thinking. Notice that this area includes operations as well, but it approaches them from a generalization view rather than the specific solution used that we saw previously. We'll also see how this area of domain moves into ratios and proportional relationships, expressions and equations, and functions as students move into the middle grades. So let's take a look at how operations in algebraic thinking build across the grade levels. Students begin their study of operations in algebraic thinking in kindergarten, as they start to understand addition as putting together and subtraction as taking apart or from. They'll also begin to understand the relationship between addition and subtraction, and they can apply properties of operations, such as the commutative and the associative property. They'll understand the meaning of the equal sign, showing that two things are equivalent to each other. And they'll be able to represent and solve problems involving addition and subtraction. As students move into the upper elementary grades 3 through 5, they'll now add multiplication and division as they represent and solve problems. They'll also understand the relationship between multiplication and division and apply properties of operations. By the end of this grade span, students will be using the 4 operations with whole numbers to solve problems, and they'll be able to represent an unknown quantity with a variable. They'll be able to identify, generate, and analyze patterns, whether these patterns include numbers or shapes. And students will also be able to write and interpret numerical expressions. As students move into the middle grades, we bring in the concept of ratio and rate, and students will use these to solve problems. They'll be able to analyze proportional relationships and use this understanding to solve real-world problems. They'll continue to apply and extend previous understandings of arithmetic to algebraic expressions, understanding that many of the rules that they learned previously apply even when variables are involved. They'll reason about and solve one-variable equations and inequalities, and they'll work on solving problems using numerical and algebraic expressions and equations. By grade 8, students have moved on to more formal algebraic study. They'll be working with radicals and integer exponents. They'll understand the connections between proportional relationships, lines, and linear equations, and understand that you can draw a line to represent an equation, and vice versa. They'll analyze and solve all types of linear equations, and they'll begin to work with systems of equations. They'll define, evaluate, and compare functions, and they'll use functions to model relationships between quantities. This type of study will continue as they move into high school mathematics. Now let's see how measurement and data progresses through grades K through 5. You'll notice that this is formally taught only in grades K through 5, but students will continue to apply this knowledge as they move through future grades, both in their math and their science classes. In grades K through 2, students begin to understand the concept of measurement by classifying objects and using informal units of measure to measure everyday things. They develop skill in using measurement tools, and they work with everyday measurement concepts of money and time. As they study length, we'll also see them start to relate addition and subtraction to this type of measurement. In grades 3 through 5, students continue to formally measure objects, and they begin to increasingly use measurement in problem-solving applications, such as finding the perimeter, finding area, and calculating volume. We also see geometric concepts such as angles and area explored here. If we think about data, students begin to create graphs to represent data in the early grades, and they'll increasingly work on using data represented in graphs and diagrams to solve problems and answer questions. Another important consideration is the link between fractions and measurement. The progression of length measurement standards includes moving from whole number measurement to fractional increments, and this relates directly to how we use a number line when considering the relative size of fractions. Including these linear models of fractions provides yet another way for your students to make sense of fractions as a whole. Now let's take a look at the progression of statistics and probability, even though you can't see them because they're hiding behind me right now. The study of statistics and probability begins in grade 6 and runs through grade 8. Prior to Common Core, probability was taught much earlier, but with the move to provide more coherence, we now focus on this topic in middle school, where students can use their understanding of ratios and proportionality to more deeply understand this topic. While statistics and probability does not show up as a domain until middle school, it does have direct connections to operational skills that are taught in elementary school. For example, finding the mean for a set of numbers involves addition and division. Finding the range requires placing the numbers in order from least to greatest and then being able to subtract. It's imperative that students go into middle school with mastery of these foundational operational skills so that they're not held back when furthering their study of mathematics in this area. So let's explore how these standards look in grades 6 through 8. In grade 6, students are developing an understanding of statistical variability in context. Variability includes things such as the study of range. They'll be able to summarize and describe distributions, such as measures of center and deviations. This will be including things such as finding the median and the mean. Students will work with just a single data distribution at grade 6. As they move into grade 7, they'll be able to use random sampling to draw inferences about a population. They'll think about how data is gathered for statistical purposes, such as sample size and randomness, and they'll be able to do a comparison of data distributions using more than one set. Probability is a major focus for this grade level, including the concept of chance, ranging from 0 to 1, and how theoretical and experimental probability are related. Students will use probability models, such as lists, tables, tree diagrams, and simulations, to determine probable outcomes for both single and compound events. In grade 8, students begin to incorporate their algebraic thinking with statistical analysis as they examine patterns. They'll look at bivariate data, and this will include things such as constructing and interpreting scatter plots, interpreting the slope and intercepts of linear models, and looking at frequencies in a two-way table. The last progression that we're going to look at today is geometry. You'll notice that this is the only domain that shows up across all grade levels from K through 8. Let's take a look at how those standards build and how they differ from the early grades to when students finish up their study of them in middle school. So students begin their exploration of geometry in the early grades by identifying, describing, analyzing, comparing, creating, and composing shapes. They'll begin to reason with shapes and consider attributes as well. Students will also begin the concept of part-whole relationships in geometry as they partition circles and rectangles into halves, fourths, and thirds. They'll also begin to partition rectangles into rows and columns of the same size, thus laying a foundation for using arrays in multiplication. In grades 3 through 5, students continue to reason with shapes and attributes, beginning to develop a classification system for shapes that are based on attributes such as sides and angles. Students are introduced to the concept of angle types, such as right, acute, and obtuse, and line types, such as perpendicular and parallel. They continue partitioning shapes into parts with equal areas as the first step in developing a visual association for unit fractions. The coordinate plane is also introduced, and students will work in just the first quadrant of this as they solve problems. By grades 6 through 8, students will continue to work with the coordinate plane, but now they will be using all 4 quadrants. They'll build upon their learning of measurement in earlier grades as they apply concepts of surface area, volume, and angle measure to solve problems. They also use their knowledge of proportional reasoning to solve problems involving scale drawings. Congruence and similarity are explored using transformations, such as rotations, reflections, and translations. And students will also learn about and solve problems using the Pythagorean theorem. So why do we worry about the progression of mathematical domains? Well, if you think about it, this is where we started. The Common Core standards started by thinking about the logical structure of math and children's cognitive development. And from there, the progression was divided into grade level standards and further refined. You also need to think about the fact that your students have a past, a present, and a future in mathematics. Prior to you, your students did learn about mathematics. Even kindergartners coming to school know something about how math works, perhaps not formally, but they have learned about it by interacting with numbers and quantities in their own life. During this year, you'll be teaching your students some specific grade level mathematics. Standards-based teaching is immensely important to make sure students develop the foundational knowledge that they need in the future. And if you think about next year, your students will use what you have taught them to progress even further in mathematics. The math they learn next year and the year after that is dependent on what they learned previously. Knowing what comes next can help you address potential gaps or trouble areas now before they compound as the years go by. So we've taken a deep look at the content standards for mathematics and how they build across the grade levels. Now let's make a shift and take a look at the standards for mathematical practice, also known as the SMPs. These standards apply to all grade levels K through 12, and they're taught in conjunction with the content standards. The practice standards describe the thinking processes and habits of mind that students develop in order to have a deep understanding of mathematics. If content standards provide what students are learning, then the practice standards describe how students will interact with the mathematics. Let's take a look at each one of them in some more detail. So as we take a look at these practice standards, I want you to keep in mind that they're written from a student's point of view. In other words, we're going to phrase them and think about them as if the student is the person doing the action, because these are what we want students doing as they interact with the mathematics. Our first practice standard is make sense of problems and persevere in solving them. I could think about this as when I'm presented with a problem, I can make a plan, I can carry it out, and I can evaluate its success. So before I even start solving a problem, I'll explain the problem to myself and kind of organize the information. I might think about, have I seen a problem like this before? I'll think in depth about the question I need to answer and think about the relationships between known and unknown quantities that are there. I might think about what tools and prior knowledge I have that could help me out. While I'm actually doing my problem solving, I persevere. In other words, I just keep going even if it gets hard. I'm going to monitor my work along the way, and I might consider changing my plan if things just aren't working out. I'm also going to continue to ask myself every step of the way, does this make sense? When I get to the end, I'll check my solution and I'll evaluate my methods. I might consider if there was a different way that I could have solved the problem. And I'll probably enjoy discussing strategies and solutions with my peers, and that can also help me evaluate if I was successful. So our next practice standard is reason abstractly and quantitatively. I use reasoning habits to help contextualize and decontextualize problems. What I mean by that is if I'm contextualizing, if somebody gives me numbers, I can put them into a real-world context. Decontextualize works the opposite way. If someone gives me something in context, I can pull those numbers out of it and work with them mathematically. Some reasoning habits that I might be working with here would be considering the units that are involved in the problems and the meaning of those quantities as well. I can use numbers and symbols when I want to represent a problem, and I might use properties to help me solve it as well. Throughout the whole process, I'm comfortable moving between those numbers and symbols and the words that describe the problem situation. So SMP 3 is construct viable arguments and critique the reasoning of others. This is one of the biggies as far as practice standards go. It means I can explain my thinking and respond to the mathematical thinking of others. I can explain my strategy, and I might do so using objects, drawings, diagrams, actions, and numbers or symbols. I can also use examples and non-examples to justify my reasoning as I create an argument for my work. When I consider the reasoning of others, I listen to their explanations and I ask questions to clarify their argument. As I compare our strategies, I look for the mathematical connections and I'm checking to see if there's any flawed logic that's occurring. Early on in school, my reasoning will usually be verbal, but as I get older, I'll be able to provide written arguments as well. So SMP 4 is model with mathematics. I can recognize math in everyday life, and I use the math I know to solve problems. If I look at the diagram at the right, these are all some different ways that I might be representing math as it happens. I'll use a wide variety of modeling tools in my work, such as numbers and symbols, geometric figures, pictures, maybe an arrangement of physical objects in front of me on my desk, or diagrams, such as a number line, a table, or a graph. There are many ways to represent math, and I incorporate what makes sense to me into my models. If I'm looking at a contextual problem, I can identify the mathematical elements, and I can create or interpret a mathematical model that shows the elements and the relationships between them. Practice Standard 5 is use appropriate tools strategically. I have a math toolbox, and I know how and when to use math tools. I know the helpfulness or limitation of tools, and I can reason if the tool I used gave me an answer that made sense. In addition to some of the physical tools that you see here on the slide, I might also use mathematical tools, such as estimation or a particular strategy or algorithm. As I get older, I can also use technology to visualize and explore predictions and assumptions, and I might even use some external data sources to pose or solve problems. Our sixth practice standard is attend to precision. I use precision when solving problems and communicating my ideas. I'm careful to calculate accurately and efficiently, and I choose the degree of precision that's appropriate to the context. I use mathematical symbols correctly, and I can describe their meanings. I also understand that numbers are flexible, and I can write numbers in different ways. For example, I know that 5 equals 3 plus 2 is the same as 1 plus 4 equals 5, and those are both also the same as 30 divided by 6. When measuring, I'm careful to minimize the introduction of error. If I'm working in a contextual situation, I make sure to specify the units of measurement that I'm using. When I create charts and graphs, I clearly label the axes and other components so that I can accurately show the relationship of the quantities. In communication, I'm precise verbally and in writing, and I'll use everyday and mathematical language to present my claims and findings. When discussing mathematics in particular, I make sure that I use clear definitions. Now let's take a look at SMP 7 and SMP 8. These are look for and make use of structure, and look for and express regularity in repeated reasoning. These two practice standards tend to be recognized less in the elementary grades, as people often think they only have to do with algebra. But there are a lot of structures that K through 8 students can encounter, so let's take a closer look. So let's look at some areas of structure that come up in K-8 mathematics. You can see that there's quite a few under just numbers, which is a main area of focus for kids in these earlier grades. The base 10 number system and the real number system as a whole are both examples of structures that help us make sense of numbers and quantities. Operations and their properties are also structures that begin with just arithmetic and continue on through algebra. If we think about part-whole relationships, this also relates to fractions, particularly equivalent fractions. And if I'm also considering algebra itself, this would be terms and coefficients and exponents. For shapes, I might consider orientation or attributes that occur, such as sides and angles and faces. And for spaces, there are lots of different types of structure. It might be dimensions, it could be a location, it could be transformations that are occurring within a space. There might be symmetry, and in particular, there might be distance as a space type of structure. In the United States, this is an area that's often brushed off, meaning that teachers often get stuck in writing and showing problems in the same way. Kids really do need support in understanding number and developing flexibility in how they're written, as well as developing generalizations to identify patterns in structure and computations. So let's take a look at our last practice standard. Look for and express regularity in repeated reasoning. I can notice when calculations are repeated, and then I can find more general methods and shortcuts. So if I'm thinking about this, I'm looking for numerical patterns in my work. I also look for regularities as I solve problems, and I can form conjectures about what I notice. I think about what I'm trying to figure out while I pay attention to the details, and I'll also evaluate if my results are reasonable. Students will need your help in seeing repeated reasoning, as it's not always obvious to them. Let them discover when they can, but make sure you have an understanding of how concepts progress across the grades, so you can help your students see the patterns that they're going to need to rely on later. So let's take a quick look at some examples that go along with this practice standard. In the early grades, it could be something such as repeated addition, and being able to understand that you can write it more efficiently as a multiplication statement. If I'm thinking about fractions, there are many different ways that I could compose or decompose a fraction because I know it's made up of unit fractions. And if I move into my middle grades and I'm working with functions, I can look at data in a table, and if I see how that pattern repeats, I know that I can write an equation to represent the pattern that I see. So now that we've learned some about both the content and the practice standards, let's take a look at some helpful hints for incorporating them into your classroom. For effective standards-based instruction, we need to target teaching the content standards in tandem with the practice standards. For example, let's say that I'm teaching 3MD-D8, which involves solving real-world or mathematical problems that involve perimeter and area. I choose a task where students are finding rectangles that have the same perimeter and different areas. I could pair this task with SMP 1, Make Sense and Persevere, so that students have to plan their approach and carry it out. And maybe I'll also use SMP4, which is modeling with mathematics, so that visually modeling what is going on through diagrams and tables can help a student make sense of the problem. My students might also use graph paper as a specific tool to visually compare the areas of the different shapes they create. That would be SMP5. So when I do this by combining those two types of standards, this is going to ensure that my students better understand the mathematical content, and it's also going to help them develop the habits of mind they need for problem solving. So my next helpful hint is that it's not just a poster on the wall. You need to actually teach your students the standards for mathematical practice. There are some beautiful posters out there that represent the standards for mathematical practice, but your goal is to make sure it just doesn't become wallpaper in your room. Use the poster to teach your students about the practice standards, what they mean, and when they use them, and explicitly point out to them when they're using a particular practice standard in conjunction with learning their math content. So remember that the choice of task is critical. You need to give them something to reason about. Tasks don't necessarily have to be real world, but they should be aligned to the standard you're teaching. They should present an interesting situation with a possibility for multiple solutions or the use of a variety of tools. They should build upon student understanding, and they should allow for multiple access points. Kids need to have something worth discussing. Just as important as the task itself is how it is presented and facilitated. Don't make the mistake of over-scaffolding and removing the opportunity for your students to think these problems through. So one of the most important things you can do to promote the practice standards in your classroom is to simply talk less. You also need to deliberately plan time and ways for your students to talk more. The more they have the opportunity to talk about mathematics, the more proficient they will become in using mathematical language to explain their thinking and reasoning. Using strategies such as turn and talk and incorporating number talks in your classroom will both go a long ways towards having your students discuss mathematics. You also need to consider the types of questions that you are going to ask your students. Try to avoid an IR type of pattern. Initiate, respond, and evaluate. You want students to talk in depth about mathematics and not just give one-word answers. Make sure you're providing tools that promote mathematics communication in your classroom. Some posters that show sentence stems and questions that students can use as they think about their own reasoning and inquire of others can be very helpful for them. Also make sure that you're providing a good model for them in your own communication. You need to make sure that you're precise with your language and that you're really talking math when you speak with your students. So our last hint is to be deliberate. You can't do all the practice standards every day. Deliberately decide which practice standards you want to incorporate into your content lessons so that you can best match student activities that will promote them. Trying to focus on them all at once dilutes their purpose, and you will find that some standards match better with certain content topics than others. I would suggest, though, that you try to include SMP1, Make Sense and Persevere, and SMP6, Attend to Precision, in your daily activities. These are practice standards that have an overarching effect in all content areas and should always try to be included. Well, that brings us to the end of this module. I hope that it's helped you understand how the math content and practice standards work together in the classroom to promote alignment to the standards. We have a resource folder available to help you implement this in your own classroom, and you're welcome to join us for another module called Features of Core Instruction Part 2, where we'll discuss teacher and student actions in the mathematics classroom.